Okay, so hello everyone. I'm Barbara Cassone. I'm a research assistant from University of Trento in Italy, and my today's presentation is about intrinsic functional connectivity fingerprinting in high-grade and in low-grade glioma patients. So, according to classical statistical approaches, one can extract a metric at the single subject level, and then it usually compares group averages between two populations, say a clinical population and a control population. However, clinical connectome fingerprinting has been gaining increasing attention lately because it allows to compare a metric extracted at a single patient level to a group average computed on a control population, but also to compare it with the group average of computed on some patients belonging to the same clinical population, and also to compare the same metric extracted on the single patient across different sessions, which can be test and retest sessions acquired during the same day or in more follow-ups. And what it has been found is that because of patients' functional connectivity profile reorganization or disorganization, patients are less identifiable among their own population with respect to healthy controls. And then the similarity or dissimilarity of each patient functional connectivity profile to the group average functional connectivity profile of an healthy population is able to predict the patient's cognitive outcome in clinical tests. So taken together, these results suggest that clinical connectome fingerprinting is a promising tool for predict patient cognitive outcome and plan a personalized treatment. But until now, it has been applied only for neurodegenerative disorders. So as far as glioma patients are concerned, previous attempt tried to identify functional connectivity fingerprints, and they found typical patterns, especially in patients with higher tumor grade. But this investigation was only focusing on language and semantic functional network. So in this study, we aim at investigating whether presurgical intrinsic functional connectivity, both at a whole brain level and taking into consideration multiple functional networks, can reveal grade-dependent differences in patient identifiability. Resting state functional connectivity data were acquired before tumor resection surgery from 13 high-grade and 13 low-grade patients, together with neuropsychological assessment. And after pre-processing, data were parceled into 379 brain regions, both subcortical and cortical, where tumor mask box cells were excluded from the bold signal average. And then two functional connectivity matrices, the test and a retest matrix, were computed for each patient. The first one from the first half and the second one from the second half of the total acquired volumes. And then all functional connectivity matrices underwent a principal component analysis procedure in order to improve patient identifiability. Then four fingerprinting metrics were computed. First is I-self, which is the correlation between each patient functional connectivity profile with his own connectivity profile across test and retest session. Then I-others is the correlation between each patient functional connectivity profile to the one of other patients belonging to the same clinical population. I-diff is the difference between I-self and I-others, and it suggests how much a patient is univocally identifiable among his own population between test and retest, while minimizing similarity with other patient functional connectivity. And finally, I-clinical is the correlation between high-grade patients and low-grade patients' functional connectivity. The first result is that iClinical scores were able to predict high-grade patients' performance in attentional matrices test. But at the whole brain level, permutation testing did not show any significant difference in any of these four fingerprinting metrics, but just a not significant trend, according to which high-grade glioma patients were more identifiable with respect to low-grade. So we went edgewise, And for each edge connecting each possible combination of our brain regions, we computed intra-class correlation. So edges with higher intra-class ICC values were considered to play a higher role in univocally identifying each patient. So we order the edges according to their ICC values from the most reliable to the least reliable, and we computed ISELF, IADERS, and IDIF for an increasing number of edges until the full connectome is covered. And this time we find a significant effect in the same direction as before. So with high-grade glioma patients being more identifiable with respect to low-grade. Finally, mean edges were ordered according to Yale functional networks, and we computed mean ICC between high-grade and low-grade glioma patients, and we found that dorsal attention between and within network connections gave an higher role in identifying high-grade glioma patients with respect to low-grade, meaning that somehow these connections are more heterogeneously reorganized among patients belonging to the high-grade population, and so they somehow help better in identifying each patient. On the contrary, somatomotor and visual network connections were more identifiable in low grade with respect to high grade patients. So, in conclusion, we found that high grade patients were more uniquely identifiable with respect to low grade, probably because of faster and more aggressive tumor growth, and that specific resting state functional networks were more heterogeneously organized depending on the tumor grade. Also, functional connectivity fingerprints were able to predict high-grade glioma patients' performance, especially in the attentional domain. And finally, even if more work is, of course, needed, functional connectome fingerprinting may help identifying biomarkers of plastic functional connectivity reorganization in patients, and thus to guide personalized treatment and rehabilitation plans. So I would like to thank you, and also greetings from the MRI method groups and the Santa Chiara Hospital team in Trento.